Hello students, in this video we are going to discuss Cbse class 9 physics chapter 10 work and energy. So we've already discussed the first few topics, that is we've completed almost 3/4 of the chapter, and we have just one small part left out in this chapter that we'll discuss under this part 6. Okay, so we will be discussing law of conservation of energy, and we'll also discussing about power or the rate of doing work in this video. So with this video we are completing with all the concepts related to work and energy, children. Now let's get into this concept of law of conservation of energy. Okay, so this law of conservation of energy states that energy can neither be created nor be destroyed. So already we learnt about various forms of energy and various types of energy conversions also. So in that we learnt that if you have a fan, you can see that the electrical energy is getting converted into wind energy. Okay, so the energy here is never lost. Okay, energy is only transformed from one form to another. The same thing applies to any other type of energy which you might come across. Is it clear, children? So this is the law of conservation of energy, and you can see that here while you throw this ball, you can see that energy is transferred from the ball to the pins. Okay, energy from this ball is getting into the pins, but there is no loss of energy. Loss is not at all there. So that is where we say that the energy is getting conserved. Energy is getting conserved. So this is one basic example. Another one would be a concept of the simple pendulum. Okay, you would have learnt about it in lower classes, children. So when you see a simple pendulum, okay, you can see that when you just pull it to one corner and then when you leave it, it moves under the law of conservation of energy. So here we are going to learn in detail about the law of conservation of energy relating to the free fall of an object. So to learn about this, we are considering the example of the ball on the top of a building. For example, you have a big building. So the top of a building, you are going to consider a ball which is placed. Okay, and when you are trying to lift the ball, what will happen? The ball gains potential energy. The potential energy is at its maximum here. Okay, and as it goes down, the potential energy decreases and the kinetic energy increases, and when it reaches the bottom, we can see that the potential energy will be equal to 0 and the kinetic energy will become maximum. Okay, so all these concepts I taught you about how work is done on the object and work is done by the object. So here we are going to consider three cases of the ball which is falling from the top of the building, and it is going to fall down due to the gravity. Okay, it is going to fall down due to the gravitational force. That is the free fall concept. Okay, so now you have point A, point B and point C. I have one small trick for you to remember. So whenever you see about potential, what is the potential? What is your potential? The potential means you can do something, or if the teacher is going to say a potential is to score center, it means that you can score center. That is your potential. Okay, and when you learn about kinetic energy here, in kinetic energy you are going to see what was completed. So how much energy has been wasted by driving means what is over. Okay, so what was done. If you remember these two keywords, going on with the derivation is going to be very simple, isn't it? Is it clear, children? So look at the first thing. The ball is at point A. At point A, we know that potential energy is going to be maximum and the kinetic energy is going to be 0. Okay, so here you can say that the formula for the potential energy is what? For any energy is nothing but your work done, which is nothing but F into S. So what is your F? F is equal to mg, and S is the distance it can travel. Okay, when you talk about potential energy, you need to see this keyword. What it can travel from the top of the building, it can travel a height h. So this S will become h. Is it clear, children? So this is how you are getting this potential energy. P is equal to mg into h. Okay, so this is the maximum. So when you talk about kinetic energy, it is 0 because the object is at rest. At this point, the object is at rest. So your velocity will be 0. So when you want to apply the formula for kinetic energy, half m into v square minus u square. So we are using only v square here because it's starting from rest. U is equal to 0. But v is also equal to 0 because it is still at rest. Okay. So kinetic energy is 0. The second case is between A and C. It is somewhere here in between. Okay. At this point, you can see that this ball has traveled. Okay, has traveled a distance x, and it can travel a distance h minus x. Okay. So this is what it was done. So when you talk about kinetic energy, when you need to take some distance s, in that case you will take s is equal to x. Likewise, when you take potential energy for the same point B, okay, for this your S will be taken as H minus X. If you remember these two alone, everything else is going to be easy, children. Why? Because potential energy means what it can do. At point B, it can travel a distance of H minus X. And at point B, what was done? The distance X was covered. Okay. So now first we are taking a third equation of motion which we will do for the kinetic energy. So v square equal to u square plus 2ax. Here u is equal to 0, a is equal to g, and instead of s it is going to be x. So v square equal to what? 2gx. So now substituting it here. So 2 and 2 will get cancelled. You will get mgx. So you got for the kinetic energy. For the potential energy, what is it? H minus x. So what will it be? mg into h minus x, which is going to be mgh minus mgx. Okay. So in that case, you can see that here we have got it. So mg into h minus x. So we have mgh minus mgx, which is the potential energy, and then we are adding the kinetic energy also. Thus, we are getting the total energy at B is to be mgh. See clearly, children, here also you have mgh and here also you have mgh. Okay. So what is the total energy? Total energy means you are adding the potential energy and your kinetic energy. Here kinetic energy was 0, so we wrote the potential energy around directly. But here we have both kinetic energy and potential energy. So even then when you are adding up both, you are getting only mgh. Is it clear, children? Because the mgx and mgx is getting cancelled. So you've done from A and at point B. Now we will have to do for point C. So at point C, you can see that at point C, can it travel any more height? No. So your S is going to be 0. This is for your potential energy. At point C, what will be for your kinetic energy? It has traveled a distance of h. So your S is going to be h. So now since S is going to be 0, directly potential energy will also be 0. Okay. But here, while you want to do for the kinetic energy, look here, children, v square equal to u square plus 2as. Again u is going to be 0. So u square plus 2gh, or v square is equal to 2gh. What is the formula for kinetic energy? Half mv square, half m into 2gh. 2 and 2 will get cancelled. So we are again getting mgh. So your kinetic energy is mgh. Your potential energy is 0. Therefore the total energy at C is going to be mgh. Now look at the results, children. We have got that the total energy at A is equal to total energy at B, which is equal to total energy at C. Okay. Since the total energy at all three cases are the same, okay, though there were different types of energy here, we can see that the ball, when it is moving down, we see that though the potential energy and kinetic energy may keep varying at every single point, the total energy is going to remain constant. Is it clear, children? So this is the law of conservation of energy. That means the total energy is what? Is remaining a constant, whichever place you might take it. Okay. So this is all about the law of conservation of energy. So this is the last topic now, rate of doing work. So rate of doing work means what? At what rate you are doing a work. So that is nothing but your power. If I have more power, the rate of doing a work would be easy. For example, if you can write 10 pages in 10 minutes, 10 pages in 10 minutes, and if another person can finish only 5 pages in 10 minutes, who has more power, children? You can see that this person has more power. This person has more power because the work done in a given amount of time. Is it clear, children? So this is more power because more work is done in a given amount of time. Here less power. So when you do it, what you will have? So thus we derive the formula for power, that is nothing but your work done by time taken. Here in this case, work done by time taken will be what? 10 by 10, which will be 1. So here what will it be? It will be 5 by 10, which will be 0.5. So clearly from this you can say that 1 is greater than 0.5. So more power is where the rate of doing the work is also going to be more. Is it clear, children? The SI unit of power is 1 watt. The SI unit of power is 1 watt, or it can be written as kilogram meter square per second cube. How are we writing that? We know work done is what? Force into displacement. Okay. So for force we will have kilogram. For force you will have what? F is equal to m into A. Okay. So kilogram meter per second square. Okay. And then what do you have? You have displacement. So displacement is in terms of meter again. Okay. And then you have one more t here. So that t is another second. Okay. So one more second is here. So what you will have now? Kilogram meter into meter divided by s into s square. So from this we wrote kilogram meter square per second cube. Is it clear, children? So even this you need to learn, children, because when you go to higher classes you might need to remember all these things. So now let's know the commercial unit of energy. So when we are going to calculate energy in our houses, okay, so calculating it in terms of what is going to be energy in terms of joules is all going to be very, very difficult. So we always use this measurement of 1 kilowatt hour. How much kilowatt of energy we are going to use in the kilowatt of power you are going to use in a given hour. Okay, so that is how you will calculate. So for that, 1 kilowatt is what? 1000 watt, and 1 hour is 3600 second. So 1 kilowatt hour will be 1 kilowatt into 1 hour. So it's going to be 1000 into 3600, which is nothing but 3.6 into 10 power 6 joule. Is it clear, children? So when I asked to calculate the commercial unit of energy, like you will have to do this. Okay, so you will not be asked much questions in this for you now, but it is still better to learn about this, children. So with this we are completing this topic, children. So hope you have understood this. If you have any doubt in any of the concepts in this chapter, please get back to the respective videos and try to go through them once again. So if you need any more videos or anything else, so you can please leave your suggestions or your comments in the comment section, children. Thank you, children.